Hello grade 10 students, welcome to another virtual class. I am Miss Madhu Vadke. We are studying chapter 8 Introduction to Trigonometry and we are learning how to apply trigonometric identities in solving questions of exercise 8.4. In today's video lesson, we will prove some more identities using the basic identities that we have studied. Let's recall those identities. Sin square theta plus cos square theta is equal to 1. 1 plus tan square theta is equal to sec square theta. And the third identity is 1 plus cot square theta is equal to cosec square theta. We have already solved question number 1, 2 and 4 of exercise 8.4. So let's continue from question number 5. Prove the following identities where the angles involved are acute angles for which the expressions are defined. The question that is given over here is also an identity, which we have to prove by using the three basic identities. So what we will do is we will prove the left hand side equal to the right hand side. We will start from the left hand side and simplify and arrive at the right hand side. So left hand side is equal to cosec theta minus cot theta whole square. In order to understand how we can develop the steps, we must look at the right hand side. The expression on the right hand side has cos theta, and on the left hand side we have cosec theta and cot theta. So the first thing that should come to your mind is to write cosec theta and cot theta in terms of sine and cos. Once we do that, we can add these two terms and then see what we get. So cosec theta can be written as 1 over sine theta minus cot theta can be written as cos theta upon sine theta in brackets raised to the power 2. Now what we can do is, we have two terms here and the denominators are same, so we can add the numerators directly. So we get 1 minus cos theta divided by sine theta whole square. This is same as 1 minus cos theta whole square divided by sine square theta. I've separated the power for numerator and denominator. Now compare what you have got with the right hand side. In the numerator we want 1 minus cos theta. So here we have got 1 minus cos theta, but it is raised to power 2. In the denominator we have sine square theta. So find a way of writing sine square theta in terms of cos square theta. So at this point we can use the first identity to replace sine square theta with cos square theta. And we should not expand the numerator. Why? Because we need 1 minus cos theta in the numerator. So using the identity, sine square theta is equal to 1 minus cos square theta. This was the last expression that we got. So substituting sine square theta with 1 minus cos square theta here, we get 1 minus cos theta whole square divided by 1 minus cos square theta. The numerator can be written as 1 minus cos theta into 1 minus cos theta. The denominator is a square minus b square type. So we can write the denominator as 1 minus cos theta into 1 plus cos theta. using a square minus b square as a minus b into a plus b. And what is a in this expression? It is 1 and b is equal to cos theta. So now we can see that these two brackets are same, so we can cancel them and we get 1 minus cos theta divided by 1 plus cos theta. Is that what you need on the right hand side? Yes. So once you show left hand side equal to right hand side, the identity is proved. Question number 2. Cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A is equal to 2 sec A. So let's start simplifying the expression on the left hand side. On the left hand side, the ratios are already written in terms of sine and cos. So what we can do is we can add these two expressions and simplify. To add the numerators, we need to make the denominators same. So we will multiply the first expression with cos A divided by cos A. When we multiply same quantities to the numerator and denominator, it does not change the expression. Plus 1 plus sin A divided by cos A. Now we need to multiply this expression with something so that the denominators will be same. So we are going to multiply the second expression with 1 plus sin A divided by 1 plus sin A. Again, I have to multiply the same quantity to the numerator and denominator so that the expression does not change. This is as good as writing equivalent expressions, like you write equivalent fractions. So this is equal to cos square A divided by cos A in brackets 1 plus sin A plus 1 plus sin A whole square divided by cos A in brackets 1 plus sin A. Now these two expressions have same denominators, so we can add the numerators directly. Denominator will be cos A 1 plus sin A and the numerator will be cos square A plus 1 plus sin A whole square. Now this expression can be obtained directly from this step. Observe that the denominator is the product of both the denominators, cos A into 1 plus sin A. And when we cross multiply, we get the numerator. So cos A into cos A is cos square A. 1 plus sin A into 1 plus sin A is 1 plus sin A whole square. I have explained here in length so that you understand how we have added these two expressions. You will be able to relate it is the same process that we use to add two fractions with different denominators. Now we need to simplify this expression further, but let's simplify each term one by one. So first we will simplify this bracket, which is of the type a plus b whole square. So we can expand this bracket and write it as a square plus 2ab plus b square, where a is 1 and b is sin A. So after expanding, we will get cos square A plus 1 square plus 2ab, that will be 2 sin A, plus b square, that will be sin square A, divided by cos A into 1 plus sin A. Now we have cos square A here and plus sin square A here. So we have an opportunity to use the first identity. So sin square A plus cos square A, I'm writing together. Then I'm writing this term plus 1 plus 2 sin A divided by cos A 1 plus sin A. So sin square A plus cos square A is 1. Write down the remaining terms as they are. Notice that I am not simplifying the denominator by multiplying cos A to the bracket, because I can foresee that the numerator is going to give me 1 plus sin A, which is going to get cancelled. But if you multiply cos A with the bracket, it is only going to complicate your work and you will never arrive at the right hand side. So you will have to use this kind of logical thinking in order to arrive at the right hand side. So this is equal to 2 plus 2 sin A divided by cos A into 1 plus sin A. Now we can take 2 common from these two terms. So we get 2 in brackets 1 plus sin A divided by cos A into 1 plus sin A. So this bracket can be cancelled. We are left with 2 into 1 upon cos A. And we know that sec A is reciprocal of cos A. So we can write this as 2 times sec A. And this is what we have to show. Thus, left hand side is equal to the right hand side. And the identity is proved. Subpart 3 is a lengthy answer. So let's do it in the next video class. Right now we will move on to the next one, which is the fourth subpart. Let's start from the left hand side. We have 1 plus sec A divided by sec A. Notice on the right hand side we have sin and cos. So we must write sec A in terms of cos A. So we get 1 plus 1 over cos A divided by 1 over cos A. Adding the terms of the numerator, we get cos A plus 1 whole divided by cos A divided by 1 upon cos A. Now we can write this expression as cos A plus 1 in brackets divided by cos A. To simplify this expression, you will take the reciprocal of denominator and multiply it to the numerator. So here we multiply cos A upon 1. So cos A and cos A get cancelled and we get cos A plus 1. Now look at the expression that we want on the right hand side. We want sin square A in the numerator and 1 minus cos A in the denominator. So what we can do is multiply this expression with 1 minus cos A. So I'm going to write cos A plus 1 as 1 plus cos A. It is still the same. Now I'll multiply this expression with 1 minus cos A. Since I multiplied this to the numerator, I must multiply same quantity to the denominator. Multiplying same quantities to the numerator and denominator does not change the value of this expression. Now why did I do this? Because I know that on the right hand side there is sin square A. And using the first identity, if I get 1 minus cos square A, I can replace that by sin square A. And here in the numerator I have A plus B into a minus b, which I can write as a square minus b square, where a is 1 and b is cos a. So this will be 1 square minus cos square a divided by 1 minus cos a. And now I can make use of the first identity and replace 1 minus cos square a with sin square a. And this is what is on the right hand side. So this identity is proved. Now in the textbook you are given a hint to do this question. You can solve the left hand side and the right hand side separately. So when you start from the left hand side, you simplify and you arrive at cos a plus 1. You can stop over there, and then you can start simplifying the right hand side of the identity. Simplify this and arrive at the same result, that is cos a plus 1. Since both sides will be equal, the identity is proved. With this we come to the end of this video lesson. Your assignment for today is to prove following identities. See you in the next class. Until then, goodbye.